This is chapter 3-1, proving lines in parallel. Please copy your cuts. Alright, this chapter right here should be very easy. We're doing the converse of the parallel lines cut by transversal. Therefore, we've got more postulates and theorems to learn. We're going to start with postulate 16. And just a reminder, we don't want to fixate or focus on memorizing postulate numbers, but more importantly, remember postulates and theorem names. So, we have corresponding angles converse, and we should remember what the word converse means. It's the opposite when we switch the hypothesis and conclusion on if-then statements, on conditional statements. So, we're getting ready to do the opposite of the corresponding angles postulate. And it says, if two lines are cut by a transversal so that corresponding angles are congruent, then that means that both of the lines J and K in this example are going to be parallel. If we quickly flip back to 3-3, when we had that, it was postulate 15 that was called the corresponding angles. And this one, it said if two lines, remember the lines were in front, are cut by a transversal, then the pairs of corresponding angles are going to be congruent. Now we're switching and putting the parallel lines at the back in our now 3-4 lesson. So now it says that two lines are cut by a transversal so that corresponding angles are congruent, then they are parallel lines. So here we have line J is parallel to line K, thus meaning that my two corresponding angles are going to be congruent. Moving forward, again, now it's just the converse. And a reminder that converse statements, again, are just the opposite of conditional. And you need to remember that converse statements of true conditional statements are not always true. So if I switch the hypothesis and conclusion, that doesn't always mean that the converse is going to be true. Just to remember that. All right, here's a theorem. Okay, now we're doing the converse of the alternate interior angles theorem that we learned back in 3-3. And the converse says if two lines are cut by a transversal, so lines J and K are supposed to be parallel, and the alternate, if the two alternate interior angles are congruent, then that means that both of these lines are parallel. So notice now the difference between the converse and the original doesn't have that little marker to say that these two lines are no longer parallel. Now what the focus is saying is that when I have alternate interior angles and they are congruent, then that automatically leads you to be able to say that these two lines, J and K, are parallel to one another. So because the alternate interior angles, again, are congruent, then that means that line J is congruent to line K. And here it is. If angle 1 is congruent to angle 3, which are alternate interior angles, then, my if-then statements, then line J is parallel to K. Okay, so that's the converse. You can go back to chapter 3-3 and look at the alternate interior angles. And then this is the converse for it. We have theorem 3-9, which is the consecutive interior angles theorem. Again, it no longer says that lines J and K are parallel. Now what you're automatically told is that two consecutive angles, the measure of angle 1 plus the measure of angle 2 is, we know, we're told that they are equal to 180 degrees. They have a supplement value. Well, they're just 180 degrees. They're not next to directly like so here, like a linear pair. But anyhow, angles 1 and 2 equal 180 degrees. Then if that's true, that means automatically that we can say line J is parallel to line K. Okay? And again, this is the converse to the consecutive angles theorem, which we learned back in 3-3. And if I flip back to our original 3-3, here's our consecutive angles. This was the original theorem we had. It said if two lines are cut by a transverse, two parallel lines are cut. We were told up front that the two lines were parallel and they're cut by a transversal. Then we could say in this time that the two consecutive angles will equal 180 degrees. Now in the converse, I don't say that. I say up front that I have two consecutive angles that we know are equal to 180 degrees, therefore meaning that my two lines, J and K, are parallel. Moving forward, Theorem 310 is alternate exterior angles. Again, it does not say that lines J and K, because I'm proving or stating the converse. It does not say that lines J and K are parallel. In this particular case, what is being said is that if two lines are cut by the transversal, so if lines J and K are cut by a transversal, and the exterior angles, alternate exterior angles, angles 4 and 5, for example, are congruent, then you can assume that line J is congruent or parallel, to line K. So if angle 4 is congruent to angle 5 by alternate exterior angles, then you can automatically say that line J is parallel to line K. And you can begin to mark your lines like such. All right, you're on page 151 of your textbook. There's an example 1 proof for alternate exterior angles, converse. And just remember the steps that you have for writing proofs, Step 1 is to write the given information and draw a picture of it. What we're given is this diagram, so we don't have to draw a diagram. It's provided for us. And we also are given a written diagram that says angle 1 is congruent to angle 2. Looking at the diagram, we're asked to prove that these two lines are parallel to one another. Line M is parallel to line M. When I look at this, what do I see here? I see angles 1 and 2 are congruent, which takes me to step 2. We know it's proved. Now I can go to step 3. I think in my head, if I'm looking at this diagram and I'm asked to prove that these two lines are parallel, M and N, I look at the diagram and I think to myself, wow, what do I know? What definitions postulate? And they tell me that angles 1 and 2 are congruent. And when I look at angles 1 and 2, I say, wow, those look just like those could be alternate interior angles. So I will write that down and think, maybe I can prove this by alternate interior angles some kind of way. It's just one idea, okay? Remember, in proofs, there's many ways to write a proof. So here we have for statement 1, I know that angle 1 is congruent to angle 2 because it's given. I know that angle 2 is congruent to angle 3 by a vertical angle, so I threw that one in there. Okay? Then I go a little step further, and I say angle 1 is congruent to angle 3 by transitive property. 1 is congruent to 2, 2 is to 3, then that means the first and third are congruent by transitive. Therefore, meaning that angle, not the angle, but side M, or line M, is parallel to line N by corresponding angles postulate. All right, thank you.